This is in continuation of the last chapter number 8. Now this is the chapter 9. Here I was describing the motions characteristic with the representation of graph. And now following this, I will now in this chapter I will teach you how to read this graph and what are the information that you can gather from the graph. So as I said, the motion may be of a kind 1D, 2D and 3D. And what are those implies? It implies 1D is when the motion is linear, that means it is following a single line, there is no other component of the motion is there. 2D when the motion is following two directional motion, like that if I standing some on the roof and I'm throwing some pebble or a ball, it will fall in following a curved path. There must be two directions where the distance covered this may be due to the some motion, and the natural the gravitational force will pull it down to cover the height. So there is a two-dimensional motion. So this is the one that I will discuss later. And 3D, if any motion is there which is be a three-dimensional, that means if I consider a closed vessel and some gas is kept here, so their motion can be of any direction, that is random motion. So any kind of random motion falls under this. Okay, so this is a three-dimensional motion, that's for gas molecular motion, that comes under this 3D. So now I will only consider the 1D motion and the characteristic or the tools that I will discuss. It is your displacement, your speed and acceleration against the time that we are studying right now. So now as I progressed and reached the graphical representation of that, now every graph will give you some information and that you have to understand. The first graph that I will discuss, that I already discussed but still I will come to that, is the graph the S against T. S is the displacement against the time. Okay, so in this graph, if I draw a straight line with a constant slope, what does it give? It gives a constant slope, and the slope will always be same everywhere. If I take any segment of part, it will give you same angle, and let's say it is theta. And how does you will able to calculate theta? If you want to calculate theta for any time span, let's say if I consider this time span and two position vector, let's say this curve will give you the velocity, and the velocity here it is constant, that I have read. How? Because s by t is constant. So s by t is nothing but the velocity, and this represent the curve slope. Velocity is the slope of this curve. Now if slope of the curve is velocity, so tan theta is your slope for any straight line, and the slope we will calculate with the vertical part of, if it is a triangle form between any span, let's say this is denoted by S2 and T2, for this is S1 by T1, that means at T after T time it is achieving a displacement S1, and that of this is it will achieve a distance S2. Okay. So this will achieve a distance S2 in that. So these are position vector, and the difference of this is will be S2 minus S1, and the time T2 minus T1. So this will be the slope S2 minus S1 between this span, this span. So T2 minus T1, and this is nothing but the delta V because v is giving you the velocity in this curve. So s against t, v is the slope. Just remember, when time against displacement, displacement against time is plotted, v is the slope. Okay, displacement against, I will write it like that, displacement against the time curve is a constant if curve if it is a straight line, then the slope is constant and it is velocity. This is velocity, or you can write it down. This is velocity. Okay, so that means this v is the velocity and it is the slope of the curve, and it is calculated for any span where the change in displacement is s2 minus s1, and between the time span t2 minus t1, then this will be the case. So this will fetch, and the tan theta will be same everywhere if you consider any span. So that means if I consider this one, when at t is equal to displacement is 0, so if I put this is equal to 0, at t is equal to 0, it will become any displacement upon time. So that relation will convert it into this form, s is equal to vt. So that means the curve will give you the total displacement for time t with the constant slope. This is something like y is equal to mx. So there is no constant part which is here in the y axis, because linear equation, if it is that kind, what c denotes the cut point here. So that means in this curve, I am considering that the reference point is equal to start point. Just give it a thought. If the reference point from where I am studying the motion, if that is your start point, then the equation will be this kind: s is equal to vt. This means y is equal to mx. There is no constant part which is comes when that x part is, if it is x and y, x for x is equal to 0, y is equal to c only when that reference point and the start point is different. If I consider for this s and t graph, if I consider this is s, this is t, so it can only be possible there is a initial cut when the reference point and the start point is different. It could be a possibility that in exam or in solution, in any example, there may be given that your start point is that much distant from the reference point. So this is your initial distance between the start point minus the reference point. If start point and reference point is different, then you will get a certain distance from the reference point, and that could be denoted by, if this is the case for our case, then how will you read then read the equation? Now the curve will somewhat differ, and how the relation will be established then. So in that case, if I draw the curve again, t against s, now I am assuming this is 0, 0, and your start point starting something here and then a slope. So as because the slope is same everywhere, if I take any, this is the cut point, that means your velocity at this with respect to this point will have always a, what is this can be read as s, means there is always a start point. So whatever, let's say this point there is s comma t, if I drop it, so that will always be added with this constant part. Wherever I drop it, I will find a constant part. This is, let's say I am assuming at small s. So what would be s here, which would be considered in the for the curve, this straight line itself, this will be v is equal to, this will be s definitely by t for time spent t, because from 0 to, let's say t. But what is s exactly? There is a, that total s is not variable, because in that this s there could be one variable. Let's say this is denoted by, I am considering this is L, let's say, and this is S1, let's say. So S1 by T, for the curve it will be from the 0 point, the time spent, what would be your distance travels? This is the only this part. Okay, so this part, the total is S1. So this part is what? This part is S1 minus the constant thing has to be deducted. So that will give you the exact displacement upon the time span. So S1 minus L. So if I take it like that, S1 minus L is equal to V into T. V is constant because slope is constant everywhere. So if I consider L plus Vt, so that means if the reference point and the start point is different, so equation will come like this. But initial case, what was the equation? Now ultimately I can remove one, because one will be the universal. So if I consider this is s, this is s, so that distance will become s minus L. Okay, so for universal expression, s will be L plus V, where L is the initial distance, L is the initial distance of start point with respect to the reference point. Now you understand what is the importance of reference point. In case L is 0, then equation will turn into, in case L is equal to 0, S will turn into Vt when that curve will start from 0. This is a parallel shift. Okay, understand? Okay, I will move to the next graphical representation. Here, where I will draw the V against T. Now similarly, if V against T is again a straight line, and that slope will give you what? For V against T means V by T is equal to constant, and V by T gives you acceleration, the constant. Okay, so in that any curve, so that V can be established is equal to V is equal to AT. Okay, now as you have read the earlier graph, similarly if there is an initial cut of the curve, same way if I describe, so there always be a difference from the reference point 0, 0 and the start point here. So at 0, if say that velocity having some velocity u, so this will be a constant difference. If I drop it similar way, I will always get a constant here. Okay, so what is the velocity? Let's say there is v comma t for t span. So what would be my consideration for the curve? Has to be this much only, because that start is here. I have to consider the start point, not this point. This will be always the same constant will be deviated, because this will be added. So equally that line will be parallelly shifted. But my consideration has to be the curve only. So I will consider this point as my start point, and from there I will read this. So to read this from here, I will shift the reference point here. So my actual velocity v will be something v minus this constant part is u, this has to be the consideration. So that by time t has to be my acceleration. So now if we turn it, it will be something like that, and v is equal to u plus at. So this is the universal acceptance of v. The condition is that if u is equal to 0, that means if the reference point and the start point is same, then u must be equal to 0. So putting u is equal to 0, v will become at only. And if u is not equal to 0, then it has to be like that only. So this is called the first equation. This is called first equation of motion. To get my point? Okay. So the information I am getting, A is the slope of the curve, V against T. Same way, A is slope of the graph, V against T. Okay. Now again, coming to the second equation of motion, how will you bring it? So again I am considering the general form and not considering a unique one. So I will start my motion with a initial velocity, let's say, but any motion can start from 0. It cannot start off its own because any motion needs some force. But as it is kinematics, I will not consider the force, but for conceptualization you may understand that any motion will start from 0 itself. Okay, now in this motion, if I bring it back, then you touch somewhere 0. That means velocity will become 0 at some point of time. It is negative. So how can it is possible to be negative? Time you have to consider to be negative. So in that case, you think, because you know that any motion is relative, so it cannot be that time is negative. But from the time when I have considered this motion and I have considered this 0, it is not unique. So if in case I understand that motion must be started from 0, then my reference frame should be shifted here, new reference frame. The time cannot be negative, so time has to be there. So my study should start from the time of motion where it is started. So definitely that would be my time, and this time will be a forward time, after which I will achieve this initial velocity. Okay, so it's not that the time is negative, so don't read it like that. So just for the concept I described that one, but now onward I will describe with the acceptance that there is a initial velocity. Okay, let's say this is u. Now at any point of time vt, this is any position vector p, but the velocity is v, and after that time span. So what is the area in between it implies? Definitely this area somehow, maybe some empirical formula relation will be there, but ultimately it is v cross t. So v cross t, what does it mean? Because as displacement is v by t, so that I know that v is equal to s by t. The velocity is nothing but displacement upon time. So from that what I have achieved, vt, or specifically if it is it is having initial velocity, then v will be exactly this one. So that means this is definitely giving you some area. Okay, so forget about this. Now if this is giving an area, so area of that confined space is equal, if it's definitely a trapezoid, because this is vertical, this is a 90 degree, this is 90 degree, but these lengths are not same, so this is a trapezoid. So trapezoid, what is the, how will I calculate the total area? If total area denotes the displacement, because this is V cross T, anything V cross T will give you displacement. So this, specifically this curve under this up to certain point, whatever the area it is forming, if I take the sum of that, it will be the area covered by that object after a certain time t. Okay, so this will be the displacement. So this area is nothing but equal to the displacement. Now how will I get the displacement? For trapezoid it is half into sum of the parallel sides. So this is equal to V, this is equal to U. So V plus U, and the difference, the distance between the parallel lines. So what is the distance? This much distance, equal to T. So this will be your area for that object after time T, when it has achieved a velocity V. So displacement, if I assume has to be S, so S is nothing but half into V plus U whole into T. So what is that? Half into, now V for this, because where this initial velocity is U, I have already got the first law, first equation of motion is this one. Now I can replace this V value here, because that is the same curve I am following. So V is equal to U plus AT, U plus AT plus U into T. Now bring it here. So I am writing here the first law of, first equation of motion is AT, where you know all these terms. V is final, U is initial velocity, A is acceleration, T is time span. So what is that? Equal to half into, how much U is coming? 2U plus AT into T. So that gives, if I open the bracket, it will be U into T plus half into A into T square. What is that? Equal to S. So this is your second equation of motion. Okay. Now come to the third equation of motion. So I am just coming back to this. S equal to half, with this help of this equation, where I will try to put relation between V and U with S. Now you know from the first equation of motion, this is again V minus U by A. If I want to get T out of here, so T is equal to time what will what is needed to get final velocity from an initial velocity U with a constant acceleration A is V minus U by A. So if I replace it here, V minus U upon A, this 2S I can bring it this side, so this will become 2AS equal to V, A plus V, A minus V, V square minus U square. So this can be brought in shape V square, if U square been taken that side, U square plus 2AS. Okay. So this is the third equation of motion. This is the second equation of motion. Okay. Now some extension using this is called the fourth equation of motion. That again a term is called the Galileo's trick. This is based on the Galileo's trick. Galileo's trick. Basically, it says that if a uniform motion is there, let's say after t it is got s uniform motion, I am saying, and uniform motion means velocity equal to constant. So it has achieved a distance. Then after this is starting from u, has reached v. Then after it is constantly increasing in the same manner, means v minus u upon t is a acceleration. So after t it is the difference of the velocity. This is v1, this is v2. So v2 minus v1 by t is equal to v1 minus u by t. This will be same way it is go. So if it is the case, then for t is equal to 1, t is equal to 2, t is equal to 3, like that, what would be the relation among the distance it is traversed? Now if I consider for any time, let's say t, and we know the relation is equal to u t plus half a t square. So that means here u is constant, a is constant, s is only related to t. So t if I put 1, so s is equal to u plus a by 2. Let's say this is 1. If it is t is equal to 2, s1, t is equal to 2 is equal to 2u plus 2 square means 4, 2a. Okay, this is 2. If I consider t is equal to 3, then s3 is equal to 3u plus 9 by 2 a 3. Now if I deduct 2 from 1, so what is the distance traversed between second time to first time is equal to u plus, this will be 2a means 3 by 2a. Okay, and s3 minus s2 is equal to, this minus this is equal to u plus 9 by 2, that means 4, 5 by 2a. Okay, so from here you can understand that the distance traversed in consecutive time, it's only following some formula which is only this was changing. So any time between sn minus 1, if I say, it is changing with the initial velocity plus, what is that? If it is second term to first term is 3, so n minus n terms is equal to what? This is the sum of these two terms, n plus 1. So it will be n into n plus 1, n minus 1 sorry, by 2 into a is equal to 2 plus is equal to n minus half into a. This is an empirical formula. When at nth time, at any point of time, nth time, it will follow the distance, it will traverse a distance, it is s nth, you can say the distance traversed at s nth is equal to followed by this. Okay, so this is only depends on the particular time span, and other things are constant. So this you can say it will be a empirical formula, where if I know the time span for which I have to calculate, then I need not to worry about any other variable. Okay, so if I say that n is equal to, let's say, 10, So I can calculate for 10th time, 10th second, I can consider t is equal to in second. This will be u plus 10 minus half, that means equal to 9 by 9 and a half a. Okay. And similarly, if I want to relate this is called the Galileo's trick, and if I want to relate the velocity, let's see how will I find. This is v plus at. So the velocity after first second, it is equal to v is equal to u plus a. For t is equal to 1, v is equal to u plus 2a. For means I'll write it v2, t is equal to 2, v3 is equal to u plus 3a. Third equation like that, t is equal to 3. So what is the difference between v2 and va? v1, it is equal to a, and v3 minus v2, it is a. So that means this is also true that velocity change in between any span is equal to constant. Okay. So now if I consider it for any height calculation, if I consider that some ball is being dropped from any height, so what is the distance it will traverse in each time? So from here, u is equal to 0, initial velocity 0, because if it is dropping from rest, and let's say this is the total height h. So for first time, or don't consider, because this I have not taught you, so let it be the linear. So in this case, if I consider u is equal to 0, starting from 0 it has pushed, and then in this case the equation will be, the first is equal to ut plus half at square. Now I consider u is equal to 0, that means the equation will become s is equal to half at square, only depend on the acceleration. Now for s1, half a, first equation on t is equal to 1, equal to 3 by 2, what is that? T square means 4, 2a, t is equal to 2, s is equal to 3, that means 3 to 9 by 2, the t is equal to 3. So if it is the case, now considering the same distance s2 minus s1, it will be 3 by 2 a, s3 minus s2, it will be 9 minus 2, that means equal to 5 by 2 a. Okay. Now this will be, now what is that? It is equal to s2 minus s1 is equal to, s1 is equal to, means at time 1 it has, if it has crossed a by 2, the distance for up to the time 1, I am starting means it is definitely s0 I am saying. So s0 is equal to 0. So s1 minus s0 is equal to half. In the next part of time, it will cover 3 by 2a. This is half a. This is 3 by 2a. In the next span means t is equal to 2. T is equal to 3, in between it is covering 5 by 2a. So that means odd multiple of that. So that means if I say it is s, so it will be 3s, it will be 5s, and like that. So basically when initial velocity is 0, then the distance traversed will be it will be a odd multiple of the distance covered in first second. So this is actually the Galileo's trick. Okay, so this has to be known as a fourth equation. That is the fourth equation, Sn, that I have told. Sn is equal to u plus n minus half into a. That is the formulation. But this is the trick. where you need not to calculate all this. So when the initial velocity is 0, if you consider initial velocity is 0, then this equation turns into such a way that the distance traversed in first second and consecutive seconds, it will be the relation of odd numbers. That means it is 1, it is 3, and 5. Now if you can calculate, if you have to add u, then with the u it will differ only by u for any nth second. So this is the trick. This can be calculated by one simple relation. In first second how much gone, so in nth second it is the third second, this is the second second. So nth second, the relation will be, the term relation will be nth is equal to, as it is the odd numbers, it is equal to first plus n minus 1 into the common difference is 2. I am following the AP series. So AP series tells you, so by that you can easily fetch the nth term of this, the coefficient for nth second. The coefficient will be this multiplied by a, that will be the segment which is varying, plus if you add u, will give you the value of nth second. So this is enough for today. In next class I will bring more concept and followed by some numerical problem. There will be a good number of numerical problem. I will solve it for you. That will give you more clarity on this theory. Thank you.